So here is another question on displacement current. So it is given that the charge of a parallel plate capacitor, it is varying as Q is equal to Q0 sine 2 pi ft. Okay, and the plates of the parallel plate capacitor are very large and close together with the overlapping area A and separation D. Neglecting the edge effects, we have to find the displacement current. Okay, so here first what we have to do is first always write the basic format, the basic equation of the parameter which is asked. So here it is asked displacement current, so we'll write the equations. The first one is d phi E by dt, and then we have id is equal to epsilon 0 a dE by dt. This is the second way. Okay, so now the only thing which is given here is the charge Q. Okay, so now we know that the charge in a parallel plate capacitor, it is given by Q is equal to CV, where Q is the charge stored in the capacitor, C is the capacitance, and V is the potential difference between the plates. So we can write C as epsilon 0 A by D multiplied with V. Okay, there is nothing wrong with that. So V we can write as this, epsilon 0 A by D. Now if we take V by D, okay, V by D, so then we have V by D is equal to Q by epsilon 0 A. Now if you know, in the parallel plate capacitor we have two parallel plates separated by a certain distance. They have a charge, positive and negative, and then there is a electric field from positive to negative. So this voltage or potential difference between the two plates per unit length, that is the gap or separation, that is equal to the magnitude of the electric field. So this V by D, that is equal to E. Okay, E. So E is equal to this much, Q by epsilon 0 A. So here the second equation we can use. So simply we'll make the substitution. So here we'll be writing displacement current ID is equal to epsilon 0 A dE by dt. So basically that is equal to epsilon 0 A d by dt of Q by epsilon 0 A, substituting this value here, Q by epsilon 0 A. Now as per the question, the only time varying thing here is the charge, so only that will be differentiated, and epsilon 0 A, as it is a constant, will go out. So that is equal to here epsilon 0 A by epsilon 0 A dq by dt. This gets cancelled, so it's only equal to dq by dt, which is the basic definition of current, rate of flow of charge with respect to time. Now here Q is given Q0 sine 2 pi ft, so that will be equal to d by dt of Q0 sine 2 pi ft, so that will be equal to how much 2 pi f, as they're all constants, okay, with respect to time that I'm talking about, 2 pi f q0 cos 2 pi f t. So this is the displacement current. Okay, this is the expression of displacement current. 2 pi f q0 cos 2 pi f t. That is the the displacement current. So here simply we first wrote down all the expressions of displacement current, and then we manipulated them in a proper way so that we can use the data, the parameter which is given in the question, which was only this, the time varying charge across the parallel plate capacitor. So we did that and we got the result. Okay,